Okay, in this video, we're going to go over how do you multiply radicals. And specifically, we're going to look over at two methods. There's actually a couple of other instances that we could look at too, but in this video, I'm just going to go over multiplying radicals that have the same index, and then multiplying those same radicals when you convert them to fractional exponents. I'm going to show you how that works. Let's start with the first one. How do you multiply two radicals that have the same index? Now, remember what an index is. If I were to just take this problem, let's say the square root of 3 times the square root of, let's go with 6. Okay? Remember, the index is the number that's inside the crook of the arm, okay? Which is this little number right here. Now remember, when there's nothing there, we just know that it's a square. We assume that it's a 2. So in this case, what we're saying is the square root of 3 times the square root of 6. And these are probably some of the easiest ones to do, because when the indexes are the same, you simply multiply the radicands. Okay, so let me just say that again, and let me just write this out. When the indices, which is the plural, when the indices are the same number, multiply the radicands. Multiply the radicands. And remember, the radicand is the number that's underneath the radical sign. So in this case, it's 6. In this case, it's 3. Multiply the radicands and then simplify. Okay. So let's try that. So since these are the same index, 3 times 6 is radical 18. Now, can I simplify radical 18? And yes, you can. Remember how you do that. You look for the perfect square factors inside 18. So think about that for just a second. What are the perfect square factors of 18? If you can't think of it right off the bat, just go off to the side and start doing the factor tree, okay? I know it's 2 times 9. Wait a minute, right off the bat. There it is, 9. 9 is a perfect square. So you're going to go the square root of 9 times the square root of 2. In terms of simplifying, you just take the square root of 9 and you get 3. And then 2 is a prime. So there's your answer. Radical 3 times radical 6 is actually simplified to 3 radical 2. Okay, so that's one way of doing it. Again, make sure that the indices are the same. Multiply the radicands, look for the perfect square factors, and then simplify. So we'll call that example 1. Let's look at example 2. And now we're going to use the method where we're going to convert the numbers to fractional exponents, okay? So let's take this as an example. Let's say we've got the square root. Well, actually, we can do this one as well. Let's take the square root of 3 times the square root of 6. Okay, now in this method, what we're going to do is we're going to prime factor each of the radicands. So 3 is already a prime factor, so we leave that one alone. 6 is made up of radical 2 times radical 3. Okay, now we're going to take each of these individual radicands and convert them to the fractional exponent. And remember how you do that? You take, let's just call this m. We'll call the index n. And the way you do that is you take the exponent and you put it over the index. And then you have a fraction as an exponent, which is the same thing as what this is, okay? Just in a different form. So here what we have is 3 to the 1/2. Here we have 2 to the 1 over 2. And here we have 3 to the 1 over 2. Now you might remember your rules for exponents. Remember those? And those rules say When the bases are the same, you add the exponents. Okay, so here we have two bases that are the same, 3 and 3. Just add the exponents. 1/2 plus 1/2 is equal to 1. Let's just rewrite this one here. This is the leftover. That gives me 3 to the first, and then 2 to the 1/2 stays the way it is. And remember the rule, any whole number goes outside the radical, any fraction less than 1 goes back under the radical. So in this case, you're going to have 3 to the first that goes outside the radical. This one goes back under the radical using this key up here, right? So exponent is 1 over the index, which is 2. So 3 square root of 2, and you'll notice that it's exactly the same as this one. Here I just put the 1 and the 2, even though I didn't need to. Okay? So I hope that was helpful. The way you do that again, you take the radicands, do the prime factors, take those prime factors and change them to the exponential form, fractional exponent form. Find the bases that are the same, add them up, add the exponents up. If there's a whole number, bring those outside the radical, fractions go back under. Okay, I hope that was helpful.